We want to look now at geometric progressions. So what a geometric progression is a series that moves along or progresses by multiplying a number to get the next term. So instead of adding a number or subtracting a number, what we do is we multiply by a number. We can divide by a number, but that's the same as multiplying by a fraction. So if we keep it just multiplying by a number, whether the number is a whole number or it is just a fraction, then that's how we get a geometric progression. The only one we really probably won't get is 0. So we can't add 0 because we can't multiply by 0 because that'll make the next term 0. We generally don't do 1 either because that's not really a series as such. It's just a collection of the same number. So for example, if you have a look at the first one, we've got 5 plus 15 plus 45. You can see that 5 goes to 15 because we multiply it by 3. 15 goes to 45 because we multiply it by 3. So in this case we'd say the first term A again is 5, so we're going to use A again as our first term. But this time we're going to use a common ratio, not a common difference. So the common ratio, we're going to use the letter R for that, and that's going to be 3 in this case. So depending, we get it by dividing the second term by the first term and the third term by the second term. So that's how we get the common ratio. So if we have a look at the terms in this series, we want to get the next 3 terms, 3, 12, 48, we're multiplying by 4. So we multiply the 48 by 4 to get 192. We multiply the 192 by 4 to get 768. We multiply 768 by 4 to get 3072. So that's how we're going to get the 3 terms in the series. Now, just say we wanted to get the 100th term. Well, we're not going to keep going and keep multiplying by 4. What we're going to do is use this formula, and this is the formula we're going to use all the time. To find any term in the GP, we're going to use Tn again, and that's going to be equal to A times R to the power of m minus 1. If you want to find the proof for that, go look in your textbook, or you can do a search on the internet for a proof. You don't need to know the proof, but if you're interested, you can go find it there. You do need to know and remember this formula because you're going to use it in lots of questions. So let's have a look at some questions here. The first one is finding the 10th term of the series 3, 6, 12. So again, we're going to use A times R to the power of m minus 1. We need A, we need R, and we need N. So there are 3 unknowns to find the 10th term, T10. So we use A is 3 because we can see that A is 3 there. R would be 6 divided by 3, which gives us 2. And we know that we're told that we want to find the 10th term, so we're going to use n is equal to 10. So in that case, we got Tn is equal to A times R to the power of m minus 1. Do the substitution, and then we just put it in the calculator. So, and just be careful with the calculator because you are starting to use indices there. So be careful how you put it in. So in the next one, find the 50th term. We're going to ask you to leave it in index form this time. As you can imagine, some of these answers will get really large. You start multiplying by numbers, they can get really large really quickly. So just be careful. And this one's going to, the 50th term is going to be a really large number. So instead of scientific notation, we'll just put in index notation, which is just as easy in this case. So the term of the series, we can find A again. A is 3. To get to 9, we have to multiply by 3. To get to 27, we multiply by 3. R would be equal to 3. You can see the second term divided by the first one here. And we're told n terms in the series. Apply the formula A times R to the power of n minus 1, which would give us 49. And we can multiply the 3s there to give us 50. So we multiply the 3s, we add the indices. Remember your index laws, especially in this one because you're going to have to deal with indexes a lot. Find the 6th term in this series, 8, 24, 72. So A would be 8, R would be 33 because 24 divided by 8 is 3, and we want 6 terms in the series. Apply the formula 1944. The 9th term in the series, 3/4 minus 3/8. This time you have a look, you do your second term divided by your first. Again, be careful with your calculator work. You see your ratio now is -1/2. So we're multiplying by -1/2 to get our series. This one's a little bit different in a couple of ways. Firstly, it's a fraction, but also we've got the idea that we're multiplying by negative. You can always know it's a negative ratio if you can see the signs alternating. So it goes from negative to positive to negative to positive and so on. So first term's 3/4, r is minus a half, n is 9. So again, apply the formula, a times r to the n minus 1, and again put it in your calculator. It's going to be easiest as long as we do it correctly, which give us 3 over 1024. Question 5 here, which term of this series is equal to this term? So like in the APs, we've got Tn, and so we find a, we find r, we've got to find n. So we've applied our formula here because we found our first term and ratio, and we know what the term's going to be. So we start doing some arithmetic here. Divide by 5 on both sides, and then we've got to start looking at a way to do it. Now later on we're going to have a look at logarithms, but firstly these ones not necessarily needing logs to solve these ones. What we do need to know is though, if we're going to have a base of minus 3, this has to be minus 3 to the power of some number. So a little bit of trial and error will tell us that minus 3 to the power of 9 would be 19,683. So seeing our bases are the same, minus 3 is the same, the powers have to be the same because these two terms are equal. So n minus 1 would have to equal 9, which leaves us with n being equal to 10. So the hint is to have a look at and see, well, what's my base? I have to put this in terms of the same base to actually get an equivalence. And it has to be, for it to work, for it to be a term in the series, it would have to be minus 3 to the power of some number. It can't be minus 3 to the power of 2.4. It has to be in the power of some whole number. So it's not too bad to work out. Again, with question 6, we're given the term in the series is 1 on 128. So we find a, we find r, so a is 8, r is minus a half, and cn is 128, 1 on 128. So again we apply those rules. Divide by 8, so we get 1000 on 1024. Again, we're looking for the 1024 to be the power of some number that would be equal to the power of n minus 1 basically. So minus half to the power of 10 in this case will give you 1 on 1024. And just a hint that 1 on 1024 is positive and this is negative, so we'd have to have a positive power. It couldn't be a negative power here to place there. So it sort of reduces our options we can take, and that's okay. So now 10 must be equal to n minus 1, which is going to be equal to 11 for the value of n. Question 7. Second term of a GP is 10. Fifth term is 1,250. What's the common ratio of the series? So in this case, T2 is equal to 10, which is equal to A times R. And we're going to say therefore that A can be expressed as 10 on R. So we've set up our formula. Well, that was actually T2 is like R to 2 minus 1. So that's why it's only R to the power of 1. We found A in terms of R. We also know that the fifth term, a r to the power of 4, when we do the formula, is equal to 1,250. Do a substitution for a, we've got an equation in r. And then we're able to solve for r to get r is equal to 5. So again, this time we're trying to solve them simultaneously, but we've got multiplication involved. So what we need to do is just do a substitution. Get one value in terms of the other. You could have worked out with r is equal to 10 on a and then worked that into the equation here. It would have got a first, and then, but this one did say it wanted us to just find the common ratio. So we could have, once we found a, we could have found r, but it was easier to work out just finding r by itself this time. Third term of GP is 2, seventh term is 32, find the 10th term. So this time we do need A and R, but we do the same process. Set up our simultaneous equations for the third term, AR squared is equal to 2, seventh term is AR to the power of 6 is equal to 32. Again, do a substitution, A is equal to 2 on R squared, so sub that in for A. So we sub it in, 2 on R squared times R to the power of 6, gives us R to the power of 4, and we do our cancellation there. Divide by 2 gives us 16. R works out to be nicely as 2, which means when we sub it back in to the equation here, we get A is equal to half, which allows us to find the 10th term in the series, because it's going to be A times R to the power of m minus 1, which gives us 9, and it's 256 all up. The test for a GP, as we've already said, second term divides by the first this time, the third term will divide by the second, and so on and so on and so on. So in this series, 5, y, and 20, we're told it's a GP, we can set up this equation. The y divided by 5 is the second term divided by the first, would be equal to the third term divided by the second, which allows us to get y being cross multiplying. Y squared would equal 100. So we get two solutions, actually two different series that we could have as a GP, one with plus 10 as y and one with minus 10 as y, because we have a ratio that's either positive or negative in this case. So it's a little bit tricky, but just be careful of that. This time we've got the series y plus 2 plus 6 is a GP. So if that's the case, 2 over y would equal 6 over 2. Again, we can cross multiply, or you can just do some arithmetic with it. But 6 on y is equal to 4, or y would equal 2/3, solving that equation. All by knowing that the test for a GP is that you divide the terms in the series.